Okay, in this video I'm going to do an example problem for a truss calculation. This one is a little more simple than the one that I did in the PowerPoint, but I thought I would start simple. I will get another one done as well with a little bit more difficult of a truss calculation. But first I wanted to start this one a little bit more simple. Alright, so I'm given my example here. Happens to be number 1 on your worksheet. And I'm first going to draw a free body diagram for it. Okay, these are 45-degree angles. Right. At A, I have a pin. So I have reaction forces. I have a reaction force A in the Y direction, and I have a reaction force A in the X direction. This one here is a pin. So at C, I have a reaction force C in the Y direction. And then I also have a force here at point B that is 500 newtons. Each of these are 2 meters. Okay, so I have my free body diagram. Okay, so first I need to find my reaction forces. So in my reaction forces, I'm going to start with my moment. Now I know that my sum of all my moments have to equal 0. So that means that 0 equals, I'm going to look at every single one of my forces and look at the moments for each one of those. So I have RAX times 0, because the distance from this point, my pin, the rotational point, would be 0. All right, plus RAY, distance would be 0 again, plus, and I'm not going to bother trying to figure out what direction it would rotate it because it is right there at that pin. So, and these are going to end up canceling out, equaling 0. Because anything times 0 is 0. Right, I also have another reaction force, so I have a reaction force, Cy, times the distance, which is 2 meters. Now the direction that it would rotate, if it was pushing up here, it would cause it to try to go that direction, which is counterclockwise. So since it is counterclockwise, I know that it's a positive. Okay, plus, I'll go ahead and go down here on this part. I also have one more force, so 500 newtons times the distance, perpendicular distance, is right here, 2 meters. So it'd be times 2 meters. And I'm always looking at the perpendicular distance from whatever point that it would rotate at, the pin. Okay, and all of that would have to equal 0. Right, so 0 plus 0, those cancel out. So now I have RCY equals 0 times 2 plus, oh, and I just need to also figure out what is the rotation here. Okay, if it is pushing this direction, it's going to cause it to try to go like this, which is a clockwise direction. And clockwise, let's see, that's this direction. Clockwise is always negative. Okay, so my counterclockwise was a positive. My clockwise is a negative. So that means it's plus a negative 1,000 Newton meters. Okay, so I'm going to move this to the other side. RCY times 2, divide both sides by 2, and I get 500, this was meters, 500 newtons equals RCY. Okay. So I can go ahead and put that equals 500 newtons. So now I can look at these and say the sum of all of my forces in my X has to equal 0. So 0 equals RAX plus 500 newtons. So that means then that RAX equals a negative 500 newtons. So that equals negative 500 newtons. That means I need to change my arrow, showing it goes in a different direction. All right, so now the sum of all my forces in my y have to equal 0. So 0 equals, I have to look at all of my forces in my y now, out of these two right here. So I know that RAY plus 500 newtons has to equal 0. So RAY has to equal then a negative 500 newtons. Equals negative 500 newtons, which means that my arrow would be going down now. Okay, so I have all my reaction forces. Each of my reaction forces I have solved for. But I have not solved for the force within each of the members, and that's what's next. Right, so I need to break apart each one of my joints, looking at each of the members separately, or each joint separately, so that I can solve for the forces in each of those members. Okay, so at A, the joint at A looks like this. I've got negative 500 newtons. Also got another negative 500 newtons. And then I've got a force, or a member basically, going up, and I don't know that value at this point. So I'm going to call it AB. Right. Then at C, because I'm going to look at the roller next, the joint there looks like this. Now remember, on each of my members, I'm assuming that each member is under tension, so I have the forces going away from them. Okay, and then I'm going to actually put the values that I know. So here, I don't have this one yet either, so this is AC. This one is BC. And then I have a reaction force down here of 500 newtons. All right, and then B, I actually am not going to have to show B, so I'm not going to draw it, but well, I guess I could draw it up here, what B would look like, because I'm going to end up solving for AB, and I'm going to end up solving, oops, wait, I forgot one, didn't I? AC goes here. Try that again. All right, AC would be here. So I'm going to end up solving for AC. I'm going to end up solving for AB. I'm going to end up solving for BC. And so this one here, 45-degree angle, by the time I'm finished, I will already have BC and AB solved for. Okay. So let's go ahead and look at A first. I usually like to start with the pen. Some of the more difficult ones, you can't actually start with the pen. But looking at this, it's going to be our easier one because we don't have an actual, we don't have an angle to deal with on it. So I know that the sum of all my forces in my X have to equal 0. So that means then that 0 equals, my two X values here would be negative 500 newtons plus AC. So then that means that AC equals a positive 500 newtons. Because it's positive, I know it's under tension. So I'm going to go ahead and say equals 500 newtons. Right, now that I know AC, I can go ahead and change this one as well to 500 newtons. Because if it's in tension here, it's going to be in tension here. Okay. Now, sum of all my forces in my y have to equal 0. So then 0 equals my y's negative 500 newtons plus AB. So that means that AB equals 500 newtons. Right. Again, we know then that because of the positive number, it really is in tension. All right, so AB up here, I can go ahead and replace with 500 newtons. Again, if it's in tension here, it must be in tension here. Okay, so now I've got just one thing left that I need to find, and that's BC. I know that the sum of all my forces in my x have to equal 0. So that means then that 0 equals, for my x, I have a 500 newtons. It's going up, plus BC is my value of my force. So I'm going to put BC. I am looking for a y, which is opposite. So it's sine of a 45-degree angle. Okay, so negative 500 newtons equals BC sine of 45 degrees. Divide both sides by sine of 45. Okay, so that means BC equals, okay, take a moment to put that into your calculator. And so BC equals negative 707 newtons. So I can go ahead and place that in here. Notice it's a negative, so that means that this is under compression. I'm going to go ahead and change the direction of my arrow, make it 707 newtons under compression. So that means up here, it's also 707 newtons under compression. And I'm not going to leave the negative. Oh, and I need to change my arrow up here, right? Because it is under compression down here. So that means it is also up here. I'm not going to leave it as a negative because here in that direction it'd be a positive. And here in that direction, well, it's a positive x, negative y. Here we've got this positive y, negative x. So you just put 707 newtons under compression just to explain what the arrows would look like whenever we do our free body diagrams. Okay, so now I have BC. And I have covered all of my members. Okay, I'll do another one of these, a little bit more difficult, and have that hopefully ready for you on the next day.